as we welcome Mrs. Ajayi. She'll be taking us on data and control structures in Python.
Good afternoon, everyone. I would stand on existing protocol. My name is Priscilla Ajayi, as introduced by our Master of Events, and I'm taking data and control structures in Python.
Okay, so data and control structures in Python, as I introduced earlier, I'm Priscilla Ajayi, the lead software engineer of Capicase. So I'd like to appreciate the organizers of this program for the platform to speak on the given topic. So the content of the presentation is we have introduction, data structure. Under data structure, we have the list, set, tuples, dictionary, control structure. We have the while loop, the while with s, and the for loop. So straight to the presentation. The programming language in question is Python, and Python is a server-side interpreted open source non-compiled scripting language that can work on its own and it can also work with framework. An example of framework is Django, and we have several other frameworks that we can work with. So we will not be dwelling too much on what Python is, just a little introduction, but the focus of this presentation is on the data structures and control structures, because we want to believe we have a bit knowledge of Python. Everybody in this training, this workshop has a bit knowledge of Python. So it's good to have a good knowledge of data and control structures in order to help to have effective programming and code when writing your programs, and it helps to know what structure to use per time for a particular problem. So what we're doing in this slide is just to take us briefly through the data structures and control structures. Straight to data structure. The basic data structures we have in Python, there are others, but we have the list, set, tuples, and dictionary. There are other data structures like the trees, the linked list, and so on and so forth. But we just want to stay on the basic for this presentation. So they all have their unique characters, they have the way they behave, and each of them is useful for different problems that might come our way per time. So we are starting with the list. List is an ordered sequence of items, which we are aware like an array. Those of us who are familiar with other programming languages, list is just equivalent to array in other programming languages. So it has its own attribute, like I said earlier on. It is indexed. Index means that it has an address allocated to each variable that is linked, that has attributes to that particular list. So in order to create a list, we usually have it in square brackets and separated with commas. So the concept of, okay, so we can see it in this figure down here that shows P is equal to square brackets 1, 2, ty, whole. So list can take different data types. It's not compulsory it is in all numbers or whole letters. We can have mixture of number letters in one list variable. So the attributes of a list is indexed, like we said earlier on. Index means we can easily point to a particular address. Like the example that was used in the previous slide is still repeated here. We have 1, 2, ty, and whole. So if we want to print P2, it's going to give an output of ty because the address starts from 0. So the value 1 has address of P square bracket 0, 2 has address of 1, ty has 2, and whole has address of 3. So the number of elements in this list is 4, but the address is 0 to 3. And it's ordered. For every time you want to output the variable value in the list, it will always bring it out exactly the way it was stored, because it's ordered due to the index that is being used, and then you can append to a list That's an example given down there on how a list can be appended to using, there's a variable name called grades. A, B, C is the contents, and then D can be appended to it, and you can just, so that I don't do too much of reading, I'll take us back to the previous presentation, which is the Jupyter Hub that Mr. John just finished presenting. If you have the link, if you're still logged in, you can just type some of these lines of code and output it just for you to have a better understanding of what the slide is about. Other attributes is that is mutable, it can be changed. The example we have here, we have a variable called, a list variable called colors that has values of red, yellow, green, and blue in it. If we are to print color 2, that's the variable with the address index 2, is supposed to give us, it will give an output of green. Then we can as well decide to change the value of that green by calling the variable and the address index and assigning it to another value, which is black. And if we are to reprint the output at that point, it's going to give us the black, the green would have changed to black. I don't know if we can just practice that, and if I can get a feedback on it. Let me also go to my Jupyter Hub at this point. So we can create a new file. I believe Mr. John has taken us through on that. I want us to all practice just a little bit of what was in this slide. And I think we had a variable called colors. And then we have different colors in it. Let's say we have red, blue, and green. So if you print the list name called color. So after typing your line of code, there's a play button here. You just click on it. It gives, what this says is that there is a list variable because it's square brackets, which have these elements in them. And then I'm printing the value of colors, and it's giving me exactly as it was told, red, blue, green. So the change, the mutability attribute is now saying color with index address 1. What's index address 1? What's the value? Okay, so let's assume we are changing that to what color? Pink, okay. And then let's print color. So we have it changed now to red, pink, green. So that's just a little practical of what I was explaining in this slide. So I'll go back to the slide. Then you can actually duplicate in lists. It accepts it as 2 different values. It doesn't see it as duplicates. Then we have several methods that you could use on list variable, like trying to get the length, the index, to append value to it, to extend it, insert. This slide will be shared eventually, and you can just practice all these things on your own. For any form of programming at all, is easier learned and mastered when you practice more. So the next data structure that we'll be talking about is the sets. A set is unordered, unlike the list. So, and the method of creation is different. Instead of the square brackets, we'll be using the curly brackets, and it's still value separated with commas. So if you are to practice it on your Jupyter Hub, you can just have your scores or any variable you decide to name it and whatever value you want to put there. Then print it the first time, and try and print it again the second time, you would notice that it's not the same order that it came out the first time. It's coming out the second time because it's not indexed, unlike the list. So it's not the attributes of set, it's not ordered, it cannot be changed. You can't, the way we change what color did we change the other time? Blue to pink. Okay, we can't change the values of sets like that because it's not indexed. And a set doesn't accept duplicates. So if we put a set that has like the 40 is repeated twice and you print, it will only come out once because it's going to see it as duplicate. It's only picked the first. It only picks one of it and it comes out. The methods of sets, we have them here. You can also practice it on your own later on. Then the next attribute, the next data structure, we have tuples. Tuples, it has similar character to a list, but there are still some differences in them. This is indexed. Then the bracket that is used for tuple is the normal bracket we are all used to. And is the same indexing method for a list is also applicable to it. It's ordered, but you cannot change the value of a tuple. It's actually useful for when you want to solve challenges and problems that you know that the values are constant and you really don't want anybody to tamper with it. So that's the main thing tuples, the main advantage that tuples have over lists. Then we have dictionary. Dictionary, it's like JSON. It's used to store different value types, but unlike all the other ones that we've been discussing earlier on, they have just one value each. For set, it doesn't have an index. The system just arranges it the way it pleases per time. For list, it automatically arranges it from 0 up to whatever number it is. But for dictionary, it has a key and value. So this example we have here, it's a variable name called PHIS data. Then we have topic, malaria infection, category, article, year of release, 2000. So that's a dictionary is actually going to take the key and the value that is correspondent to the key. The attribute is ordered. It can be changed. You can actually use the key to change the value per adventure, and it also does not allow duplicates. The methods of dictionary is also here. You can practice it later on. Okay, so to control structures, we just finished the data structures. I don't know if anybody has any question before I move on, both online and physical. Okay, in the absence of none, I'll move on to control structures. Control structures can be referred to process of ordering the system to carry out set of instructions in a systematic way based on conditions that have been set in the system. So we have different forms of instructions that the system accepts. First, the systematic that is not written here at all. Just as you are typing the instruction, it takes it. I'll just call it like a protocol kind of control system. But the two major control systems we want to talk about here are the selection and the repetition. These ones actually give instructions, and then it continues to carry out the instruction until it is told to stop, either through a if condition or a while loop. So we have selection and repetition. Selection is for the if conditions, repetition is for the loop, either while or for loop. Okay, so selection, like I said earlier on, is the if statement, but we have different ways it can be used. There is the if, there is if else, there is if else, and there is nested if. I'll just quickly run through examples of each of it. So we have the if statements, the way it's written in Python is just a simple statement to say if, then the expression, and after the expression, you have to put every other thing that is going to text in that index is for the if statement. One same line where the if starts, then you are out of the if statements. So this is an example here. I've called initialize score to be 70. I would like to show this in the Jupyter up. Okay, so this is the line of code that was in that slide. We already have score initialized to see. So I don't want to initialize the grade. So I've commented the next line of code. So we say if greater than 7 print grade. We don't have any output at all because this code says the score has been initialized to 70, and the only thing we have taken care of is if it is greater than 70. Is if it's greater than 70. So if we initialize this to 71.
Good afternoon, everyone. So I have a question concerning the line of code, especially the inverted commas. Is there any rule of thumb whereby we have to use a specific, is it the double comma or the single comma for any particular stage? I don't want to be sure of that, or there's no rule. Anyone goes. Thank you.
Yeah, thank you for the question. So that is taking us back to fundamentals of Python. Even though we are not planning to take that here, but it's because anytime we have numbers, I believe we are used to variables, different variable types, how to collate them. So once we have numbers, we can actually put it without a quote. If it's a string, you need a quote in it. It can be double or single. It does not really matter. It takes it as far as there is a quote. But whatever, you can't use double and use single. It's either you're using double, you're starting with double quotes and you're closing with the double quotes, or you start with the single quotes and you close with the single quotes. Does that answer your question? Okay. I would, then there is the for loop. That's the next example in the line of code. Okay, so there is a little bit difference between the while and the for loop. The for loop now is looping through a list. It can also loop through its unlike loop. The while loop, we just the while the condition, there is necessarily no list to say. It depends. It depends on the problem that is actually being resolved. But the for loop, most times there is a list it wants to loop through for you to go through the value of the list one by one to actually either perform an operation or to print an output or to sum up whatever it is that is to be done. So this example in line 71, we have a variable name called list numbers with a list number 1, 2, 3, 4, 5, and they want to sum the value of the list. So we have a for, var is a variable, it could be anything. We could call it I, we could call it any variable that suits the work we are doing. So it checks if var is in the list, then there is a sum has been initialized above here to 0, then it sums it to the sum and it continues to go through until it exhausts the item in the list. Then it prints the sum of what we have in the list, which is 1 plus 2 plus 3 plus 4 plus 5, 16. This is just similar to that, to the first example too, but can someone volunteer to explain, a different person volunteer to explain line 69? Anybody?
Can we have someone? Okay, I wanted to suggest someone online.
Let's go with it.
Okay, Ashuza.
Thank you. Thank you for the floor. For the cell 69, the first line is the initialization of a list with 6 numbers. So the next line is a for loop that will loop through all the elements of the list L. So we have len L is the function that returns the size of the list L. So now range is like an iterator. So it will create like a 6 possibility because it take the parameter 6, like the length of the list. So but range starts by 0. So the generator that starts always by 0. It will start like 0, 1 to 5. So by printing the line Li, so we start by 0. L0 is the 2. It's like the 0 index in the list is the element with value 2. That's why we have 2. The next one will be 4 until we reach the end and we print the comma at the end. After every value, we print the value, we print the comma. So print /n is to say step and step to the go to the next line. It will leave like an empty space. And the second loop is 4G, is the same range. That starts the same range, the function range that they use, that starts from 0 to 9. Because range always starts from 0 and leave the last elements in the interval. It's in the range now. So now we'll have 0 to 9 because it will not print the 10 because it will stop at 9. Thank you.
Thank you very much for the explanation. It's well understood by me. I don't know if everybody, any question on it? Okay, so everybody has agreed with your explanation. Thank you very much for that. That would actually be the end of this presentation. Thank you for listening. God bless.
Thank you so much, Mrs. Ajayi. Let's put our hands together for her again. So the facilitators will share their slides and we'll put that on the WhatsApp group so that we can, go over by ourselves and familiarize ourselves with everything that's been done. All right, thank you very much. Okay, someone has a question. We'll take it real quick. For who? All right, so it's a contribution for the just concluded exercise.
Thank you very much. I'm Naju Josiah. I'm a first year PhD student. I just wanted to make few contributions to the wonderful class we just had. We've learned the practical aspect of lists. We also learned about conditional statements. We also learned about loops. But for those in the online and physical participants that have not interacted with Python, I'm wondering, how would I collaborate with this? How does this relate with my research? For example, I'm doing a research in the area of maybe patient data. How would I use lists? So I just wanted to point out some points there. So it would make sense to add both the practical aspect and also to the research. Like some of the areas I checked out is biological research for genomic sequences. Let's take an example of DNA sequences as the variable name. Then we have in the list, we have A, we have G, we have these are some of the sequences you can have. So if you see something like that in maybe a data, you can recognize that when you are using some of these tools in the practical section. Many other areas too, like machine learning for hyperparameters, text analysis and social net. These are some of the real life use cases of lists, loops, and conditional statements. Thank you.
Thank you very, very much, Mr. Uche. All right.
Thank you, Ma. I just have a little contribution to the while loop. It's also possible that we also while loop through a list. For instance, we have a list that contains number from 1, 2, 3, 4 up to 5. So the last index will be 4. So we have index 0 to 4. So then we can use the length of the list, which is 5. So we can just give out, since the length is 5, so we can use our loop from 0. Why can you say L equals to 0 as initialization? So we say while L is less than the total length, which is 5. So it means that it will run from 0 to 4. It will not pick that, the 5th one. So we can write it that way and loop it while we are using the while loop. So we can even use the while loop. We can use it for various manipulations. We can use it to add the numbers in successions. We can use it to add the square of those numbers. We can use it to add the cube of those numbers, just like we can use it in the for loop scenario as well. Thank you.
Thank you very much, Mr. Shobola. Do you have any comments from the audience?